Welcome to our YouTube tutorial on mixtures. In this video, we will explore the fascinating world of mixtures, understand what they are, and delve into different types of mixtures. So, let's get started. To begin, let's define what a mixture is. In simple terms, a mixture is a combination of two or more substances that are physically combined and can be separated by physical means. Mixtures can be found all around us, in our daily lives. Think about milk and water, your soft drinks, or even milk. These are all examples of mixtures. Homogeneous mixtures, also known as solutions, are mixtures where the components are uniformly distributed throughout. Lemonade is a great example. When sugar and lemon juice dissolve in water, you get a homogeneous mixture, where you can't see the individual components. Heterogeneous mixtures, on the other hand, are mixtures where the components are not evenly distributed. Trail mix is a classic example. You can see and distinguish the different components like nuts, raisins, and chocolate chips. Imagine pouring sand into water or observing the milky appearance of milk. These are examples of suspensions and colloids, respectively. Let's start by understanding properties of solutions, suspensions, and colloids by doing Activity 2.1 and 2.2 from NCE or T textbook. In Activity 2.1, the class is divided into 4 groups: A, B, C, and D. The materials are provided to the groups, asked to mix them, and observe uniformity in color. Group A added 1 spoon of copper sulfate, CuSO4, in 500 ml water. Group B added 2 spoons of copper sulfate in 500 ml water. Group C mixed 2 spoons of potassium permanganate, KMnO4, and 1 spoon of copper sulfate, and Group D mixed 1 spoon of potassium permanganate and 2 spoons of copper sulfate. Observations: Group A and B made uniform solution of copper sulfate despite the amount of salt added. Group C and D made non-uniform mixture. Hence A and B group made homogeneous mixture, and C and D made heterogeneous mixture. In Activity 2.2, the class is divided into 4 groups: A, B, C, and D. The materials are provided to the groups, asked to mix them. Observe the beam of light through the beaker, and filter the mixture to check for residue. Group A added few crystals of copper sulfate in 500 ml water. Group B added 1 spoon of copper sulfate in 500 ml water. Group C mixed 2 spoons of chalk in 500 ml of water. And Group D mixed few drops of ink in 500 ml of water. Observations: 1. When a beam of light is passed through the solution, the path of light is visible in C and D. This means the light is scattered by the particles of chalk and ink in C and D. This effect is called Tyndall effect. 2. The residue is observed in C only. This means the particles of chalk do not dissolve properly. Conclusion: based on the observation, A and B is solution, because there is no scattering of light and no residue on filter paper. C is suspension, because it shows scattering of light and residue is observed on filter paper. And D is colloid, because it shows scattering of light but no residue is observed on filter paper. Now, let's discuss the properties of solutions, suspensions, and colloids. Solution is a homogeneous mixture of 2 or more substances. A solution has 2 components. Solvent: the component of solution, usually in larger amount, dissolve another component of solution in it. Solute: the component of solution, usually in less amount, get dissolved in the solvent. The particles of solution cannot be seen through naked eyes. The size of particles are as small as 1 nanometer in diameter. The particles of solution do not scatter light, hence doesn't show Tyndall effect. Phenomenon in which path of light is visible. The components of solution cannot be separated through filtration method. The solution is stable and solute particles do not settle when left undisturbed. Example: salt solution, sugar solution, tincture of iodine, aerated drinks, and air. A suspension is a heterogeneous mixture, in which solute particles do not dissolve, but remain suspended throughout the medium. The particles of solution can be seen through naked eyes. The size of particles are greater than 1000 nanometer in diameter. The particles of solution scatter light, hence show Tyndall effect. Phenomenon in which path of light is visible. The components of solution can be separated through filtration method. The solution is unstable and solute particles settle at the bottom when left undisturbed. Example: mixture of chalk and water, smoke and air. A colloid is a heterogeneous mixture in which solute particles uniformly spread throughout the medium. Components of colloidal solution. Dispersed phase. The solute-like component present in lesser amount. Dispersed medium. The component of solution in which dispersed phase is suspended. The particles of solution cannot be seen through naked eyes. The size of particles ranges between 1 nanometer to 100 nanometer in diameter. The particles of solution scatter light, hence show Tyndall effect, phenomenon in which path of light is visible. The components of solution cannot be separated through filtration method. The solution is stable and solute particles do not settle at the bottom when left undisturbed. Example: milk, cheese, clouds, shaving cream, face cream, butter, mud, foam, etc. Let's practice what you've learned. Here is a crossword puzzle for you to solve. Pause this video, solve the puzzle and comment your answer. You will get the answers of this puzzle in my next video. If you have any questions or want to share your thoughts, feel free to leave a comment below. Don't forget to like this video and subscribe to our channel for more exciting tutorials on science and beyond. Thank you for watching, and keep exploring the wonders of mixtures.